All right, guys. Can you guys hear me okay? We're about to be live and we are going to be streaming on YouTube as well. So join us up on YouTube. So we're going to be doing most of the stuff there and recording as well. Welcome in everybody for the system design battle. We're going to have everybody join us very quickly. So we're going to have quite a bit of fun for the Thanksgiving special. So let's go. All right. So we have Jerry, Sniper, and Chompy. Please raise your hand and join us up on the stage. All right. Our first judge is here. Chompy, how are you doing? Oh, sounds like you have a problem with your mic. All right. We have our participants, Jerry and Sniper, here. How are you guys doing? Awesome. Awesome, guys. So, are you guys excited for the Thanksgiving special? You guys nervous? All right. So, let me let me guys have you introduce yourselves to the audience. So, we are streaming on YouTube right now. And let me go ahead and share my screen. So, we have people on YouTube as well. All right, YouTube, can you hear us okay?
Me? Yes.
Perfect.
Oh,
Awesome. Awesome, guys. All right. So Sniper, do you want to go ahead and introduce yourself first?
yeah. By the way, can you guys hear this? Discord's telling me they can't hear me.
Let's see. Can you guys
Hello?
hear the Sniper and Jerry?
Hello,
I can hear Jerry.
I can hear you.
Yeah.
Nice.
Okay.
Chat says they can hear me. Nice.
All right. So I guess Discord's lying.
All
All
right.
right. Well, I guess I'll just start with myself. So I'm Sniper. I'm currently a software engineer at Oracle, although I'm about to leave because I just accepted an offer at Amazon and I'm about to start in 2 weeks. And yeah, pretty exciting time of my life. And yeah, I'll hand the floor to Jerry.
Hello, I'm Jerry. I worked at Meta for a couple of years. One year in SF, 1 year in London. We did applied ML to essentially help people going through tough times as well as uh, other things. Um, and then I left to essentially travel the world and work on my own startups. I finished. Wait, I'm talking too much. Okay, that's it.
It's all right. Thank you guys for introduction. It sounds like our participants are super nervous tonight. So a big round of applause for both Sniper and Jerry. So we really appreciate you guys fighting for the turkey crown tonight. So that is really fun. I hope you guys enjoyed, and I wish you guys the strongest one wins. So tonight I'm gonna to introduce the problem. So we are going to be doing a turkey delivery system. So every single year, and let me go ahead and share my screen. And we're going to have, all right, can you guys see my screen okay?
Yes.
All right, so
Yeah.
every single year we have about 45 million turkeys sold in the US. So essentially what happens is that we have about 300 million people in America and only 45 million turkeys are being sold. So some people are going to be left without a turkey. So in tonight's special episode, we're going to be designing a system where people are going to be ordering turkeys on their favorite food delivery app, and your guy is going to be building a delivery infrastructure app. So logistics infra. So let's say your closest Safeway has a turkey. That's the store. We're going to be routing the driver to bring the turkey in. And you're going to have a lot of stores in your network like Whole Foods, QFC, whatever the stores are. Some of them might have turkey, some of them may have frozen turkeys only, some of them can be running low on turkey. So your goal today is to design a food delivery load balancer that would route all these turkeys coming in at the same time, and you guys are going to be battling 300 million Americans all trying to check out a turkey at the same time. So essentially, you have a grocery network that you need to follow, and in the grocery delivery network, you will have a lot of problems, such as race conditions and other fun stuff when millions of people try to check out at their local grocery stores. So some of the things that are out of scope is authentication and other boring stuff. So don't worry about, those things, and hopefully you guys are not going to have any problems. And that should be a pretty solid experience for you guys. And yeah, hopefully the problem you guys deliver will be really good.
What? Okay, you said there was a bunch of grocery stores in your network. Essentially, do we make up what the API looks like for them?
Yes, your guys going to be
Okay.
designing a full backend system for the turkey delivery network. So imagine you have Whole Foods, you have Safeway, you have QFC. You guys have access to their inventory levels. They have
Okay.
an API that they provide, and for every single consumer that lives in an area, you would want to find the closest or the best grocery store where they can get a fresh or frozen turkey.
Uh, okay. And then we have some sort of system coming in with orders, right? That's also
That's
handled, or we define that?
You guys define that, right? So you guys
Gotcha.
have a data stream. So you have for the scope of this problem, imagine you have a reliable API that basically says, all right, in this grocery store we have this many turkeys, in that grocery store we have that many turkeys, and you are
Oh,
going to be using the network of delivery drivers to route them to the customers, maybe batching orders or coming up with delivery logistics infra to deliver on all those orders to the people who are going to be checking out at the same time.
wait, so we're in charge of the delivery drivers?
Yep, you're in charge of the entire logistics network. So
Okay.
imagine you're basically building the infrastructure behind what is powering delivery for the service.
Okay, so not just the technology, but sort of like figuring out the logistics,
So
last mile.
right. So you want to have to think about something like a load balancer for the closest turkey, and think about the drivers that are available, the stores that are available. Consider store
Okay.
open hours, the ETAs, and stuff like this. So yeah, there is quite a bit of interesting stuff that can happen here, and you really guys want to put a lot of priority into making sure that the system is very realistic and has a lot of power behind it. And the judges will be picking. We're gonna have two judges tonight from the experts, and the final decider will be the audience. So you guys on YouTube and you guys in Discord, you guys gonna be deciding who is going to have the turkey crown for the episode. So yeah, that's kind of how we do it. And yeah, any questions so far?
So I guess the question I have is like in this system, or maybe if this is kind of too much to give away, like, are we assuming that the orders will come in from somebody who potentially uses an app that sort of like consolidates all these networks of grocers to, place an order for one of these turkeys?
Exactly. Right. So you basically have like a food delivery service app that you're going to be using,
Okay.
and
All right.
you're powering the logistics muscle of that food delivery app.
Okay. That makes a lot more sense now that I think about it.
Mm-hmm. And for the
Yeah, I think
numbers,
I've got a pretty solid idea of what I need to be doing now.
gotcha. Does anyone from the audience have any ideas or questions for the problem as well? Make sure we're all on the same page. So we actually have one question from Daniel, who asked if we get data feed from the grocery stores or take hints from delivery drivers. So for the scope of this problem, we're going to rely on a third-party API call from the stores itself that are going to be providing us with reliable data on how many turkeys are currently available. Oh yeah, another great question. Do customers have a preference of which store they would want to buy turkey from? So that is exactly the point of today's session. So people can be ordering from, let's say, Whole Foods, but if Whole Foods is not available, the customers may select a fallback store. So the driver goes to Whole Foods, and then maybe by the time the driver gets there, the turkey is not there anymore. So customers may select a fallback store. So
Oh,
and then we can reroute the driver to go to another store to get them the turkey.
Do customers even need to specify the store? Shouldn't it just be whatever's closest and most logistically available to them? Like, why do they care where it actually comes from? But
So
yeah.
that's your guys' design. You may add all those things as you think, as you see fit. I
Okay.
haven't really thought about all those nitty gritty details. I think, the problem is already very complex in and of itself. And you guys only have 45 minutes to deliver the results of that problem. So essentially, I would recommend you guys go ahead and try with the logistics power of it. And then if you guys think about any optimizations you can make, such as ignoring the store or looking for the cheapest price, you may present it as a feature in your design to show you have an edge over the opponent. And tonight, for the first time in our battle, the participants will be asking the opposite side questions about their design first before the judge. So for example, after the 45 minutes of design is done, Sniper will be poaching or hacking Jerry's design, and Jerry will be doing the opposite. And we're also going to be evaluating Jerry's and Sniper's performance based on the questions they ask to their opponent at the end to challenge their design. So we're going to have
Jesus.
we're going to have a hacking round as well, and then the judges from judges, experts, and the audience will be the tiebreaker for the session as well. So we're going to have quite a fun session tonight. And yeah, thanks everybody for tuning in to YouTube and Discord. We have about 100 people watching us tonight. And, I think everybody's really excited for the Thanksgiving session. So happy Thanksgiving, everybody. And if there's no more questions, we shall begin. All right, you guys ready?
Oh. No.
sounds good.
Yeah,
Let's
okay.
get started.
All right. Awesome. All right, Sniper and Jerry, I'm going to move you guys to the separate room. And if there's anything you guys have, call me in on Excalibur draw and we can continue our discussion there. Ready? Awesome.
Yeah.
All right, I'm going to move you guys right now. All right, now that they're gone, what do you think about the problem?
I'm still here.
Yeah, that was funny.
Okay, now that he's actually gone.
Now that they're actually
yeah,
gone.
So no.
Fantastic question. What do you think about the question?
Okay, yeah, this could get pretty complicated. I think it's a bit open-ended, the way it was asked here, right? So we don't know exactly how we're getting all the information we need, like which stores are where, what drivers are in our network,
Exactly.
So I'm not sure how they're gonna handle that.
Yeah, I think there is a lot of open-ended questions that can be asked here, and one of the things I kind of had in mind for the services, the logistics infra side of things. So it's actually very complex to determine this. So number one thing that I would love to see from the winner is geohash. I think it's extremely important to have, first of all, really good understanding between consumer to store location and distance, and also the delivery driver to store distance and time, right? So we really want to make sure that whoever is going to win tonight is going to have a really powerful travel and ETA service. So that is definitely one of the domains that a good design should feature. What do you think, Chompy?
Well, yeah, it's the core of the problem, right? So that's where their time should be focused the most, not like the little details that are irrelevant. So did we talk about like payment, how that's going to work, whether we have to talk about that, if certain stores are cheaper than others, if we should prioritize price versus time?
Yeah, I think that's a really fantastic question. And I think that if I were to design a system like this, I would probably create a model that ranks every single thing in a preference. So for example, if the consumer paid for urgent delivery or rush delivery, then we should be specifying in our assignment service that this consumer wants things to be delivered quickly. Or alternatively, we use assignment service to balance the preferences from the consumer. So that's where you can actually showcase quite advanced system design skills by creating a model that can power an assignment assignment engine. Imagine you can pass anything to the assignment, a list of preferences. Maybe you want the delivery driver to have a heated bag. Maybe you want the delivery driver to have a truck. Maybe you want the delivery driver to be going there on time and not batching with any other order. The assignment service in that case should contain a model that it takes for something like that, and using that model to basically help make the decision. Essentially, if the person doesn't care how long it takes, they just want the cheapest turkey, we can save some money by batching their order with a bunch of other orders and saving a lot of money. I think that would be actually a really cool idea for the winner to have a system that allows you to have dynamic assignment and batching and rush service to save those fees or to accommodate customers who are in a rush. Another big thing.
Okay, so it's the customer's choice if what they want to prefer, right? Speed or money.
Exactly. The balance between speed of money, I think, is the biggest challenge in the logistics infra in general. I think it's very important for the winner to have a really good hunch of how logistics infra would work. So I think as an engineer for system design interview, you really want to have a good understanding of what the system really does and how it really works. I think this is kind of one of the most recent things that started coming up in a system design interview, is also evaluating how good the person really understands the requirements and how well they can execute. Because most of these companies, like FAANG or FAANG adjacent companies, really focus on the candidates being able to be owners and leaders. And I believe there is not a better way to show your leadership and execution rather than thinking about the product through and through and think about all the challenges of the product. I think that's what actually makes someone a really great engineer, a 10x engineer, is that business level understanding that allows you to think about the system ahead of time and anticipate requirements that may come up and engineer the system in a way that anticipates those requirements from product and be ready for those requirements to be executed. What do you think?
I like that. For now, I do want to focus in on so we do understand there's going to be so much data, right? 300 million people ordering turkeys, right? Let's think about what do we need to keep track of that we need to persist and store in a database,
Exactly.
right? So our dashers, or sorry, our drivers, do we need, I guess, a record of where they are at all times, right? And who they are?
Yeah.
So do you think CRDB is something appropriate for this, right? Because it's huge scale, but it has to also be somewhat consistent.
Yeah.
Is that something?
I would say, since the location data is ephemeral, I would not actually be super concerned with storage. I think we can use Redis to store.
Oh, I see.
Because, if you lose data or if your data is not persistent, I don't think, it's a really that big of a deal to have something like that, lost.
Okay, that's a good point for driver location. Okay, that's fair. What
All right.
for actual orders, like logging a transaction? How about that?
Yeah, for transactions, do you mean like the actual payment and stuff?
Yeah, like noting down that, okay, this customer just ordered a turkey and that needs to be persisted and right?
Yeah.
And that needs to be super consistent.
So I think, yeah, I 100% agree. I would say maybe something like Cassandra would be good for something like so CRDB, depending on the way how it goes. I think for this type of problem, you need to already assume that the order service exists, because order service in and of itself is very complex. It is a stateful application in a way that for an order service to work for a company like this, you actually need to have really good way to keep track of state, because you can only apply certain things to orders only if they're in a certain state. So order service in and of itself in a system like this would be a very complex state machine, distributed state machine. And managing that state would be extremely, extremely challenging, in my opinion. For what I'm looking at in this problem specifically, if I would ask something like this, I would actually be really interested in solving the problem of load balancing turkeys, right? It might sound really funny, but it is actually a very complex problem, because the inventory management here is actually very complex, because so many people buying so little turkeys at the same time, you will have stores that would run out of turkey, right? So you might deploy the delivery driver to go to Safeway to get the turkey, but by the time they get to Safeway, there might not be any left. Or somebody can grab the turkey from the store, carry it in a cart. The system would not know that the turkey has left, because you basically have a faulty, no matter how good the system is, you would have a faulty inventory management, because people will take the turkey put it into their cart, and we would not actually know that they're left the shelf until somebody checks them out at the register. So I
You're-
think it's very complex in this
You're
sense.
talking about the inventory of the store itself, not our
Correct.
system.
Right, because you're competing with actual people who are in the store.
Okay. And we can query like the store's inventory. Like, is that something that's accessible to us here?
Yes, that is essentially, we have like a Whole Foods API, and for
I see.
but yeah. So some people in the chat say you need to probably have the inventory for the store and online, separate things. But the challenge with that is that actually doesn't make sense. One of the things that it would not make the design fun. If we had the separate inventory for online and the store, then the problem would be kind of like an order of magnitude easier. But we kind of want to make it fun. And our candidates are pretty senior, actually. I think Jerry is an E6 level and Sniper is E4. But I know that Sniper is actually pretty good at system design, so the problem is a little bit harder. Yeah, but why would you
Okay, so
overbook a turkey? That's really interesting.
So I was saying, so when a turkey's in the person's physical cart at the store, right? It's no longer on the shelf, but the inventory also didn't update. So basically that means our Safeway APIs are not reliable at all. We can't trust it. Is that correct?
To a degree, right? Because as soon as they check out at the register,
Then it updates.
Then it updates. Then we know the turkey's gone.
Look, we could very well be sending a driver to a store that doesn't actually have a turkey on the shelf because it didn't update yet.
Exactly.
And we have to be able to handle that.
How would you handle something like this, Chumpy?
Wow. Yeah, no. So that no matter what, the driver is not going to have a good time, right? We need to then route this driver to another store, right? Or we can be proactive about it and say, hey, there's only like 3 turkeys left. By the time we get there, they're probably all going to be gone, right? So not only look at Boolean, is there turkeys available or not, or actually look at the number of turkeys available at a given store.
Exactly. Right. I think that's a good idea. And also, don't forget that in our functional requirements, we actually also have a way for some turkeys to be, how do I say it? Well, we would want some turkeys to be delivered quickly, and some, not to be delivered quickly. So how would you handle batching and grouping the orders together?
Okay, well, if you buy priority, like speedy shipping, I don't think you should ever be batched, right? Or you could be the very first person on the batched order. Either way, you're going to get the fastest possible speed.
That is very interesting. What if everybody lives nearby and they all order a turkey? How would you handle assignment and batching in that case?
Okay, so we're talking about like a local town
Yeah.
with just one Safeway probably,
Yeah.
and a bunch of people wanting it at the same time.
Let's consider 2 things, right? New York City and then a small town. Would you separate the logic based on how big the city is?
I think the logic would less depend on big town or small town and more on like how many stores are there in a given like square
Hmm.
mile, right? I think that's what it should hinge on.
I see. I guess we can use the size of the city for for the how sparse or dense the store to human ratio is, right? So in New York City, you're going to have a lot of people who live like together. So I'm assuming the batching has to have a very small geohash scale. That's I guess how I would have thought about it, because the smaller the city is, like think about Manhattan, right? Your Manhattan city is actually very, very, very small, and it probably makes more sense to batch all the orders in GeoHash resolution 8.
I see what you're saying because it's so dense that you should actually be using smaller like
Smaller,
squares or
smaller
hexagons. Yeah.
squares.
Okay, that makes sense. And again, that goes back to what I said. It's about the density of stores, right? So it's like you might want to, it's not about drawing your square around a certain square mile size. It's about drawing it around a certain quantity of stores, right? Because in Manhattan, there might be a store in every block, right? So then your resolution size is roughly the size of a block, whereas a small town might have one or two stores. So one or two squares can cover that entire town. Does that make sense?
Absolutely. So let's get a look at some boxes. So it looks like our candidates are getting some boxes out of the way, and we have actually a really fantastic question from chat. Um, if a lot of orders happen at the same time, they will need a requirement to handle race conditions, right? Will Kafka or SQS fix that? That's a fantastic question. How would you handle race condition in this case?
Okay. You're gonna have to be more specific about what race condition would happen, right? Because is it about whose order should be completed first? If they ordered at the exact same time, it should probably be random unless one person has priority service.
That's exactly what I would think as well. I think if two people order at the same time and they live in the exact same place, how would you handle race condition? Or do you think it's even worth to handle the race condition at all? Or if we should just completely let anyone win in this case?
Honestly, if those two people have the same priority level, honestly, it doesn't actually matter at all who should go first, unless, of course, the routing, the drive from the store to the people's houses, one person's house is on the route to another person's house. Then, of
Then
course,
it's
that
very
changes
interesting.
everything.
Should we design the system to save the most amount of money for the company? Right? So
Okay,
if
so that depends if you ordered a priority order or not. If you paid extra for priority, then we cannot prioritize ourselves for that. We have to prioritize the customer.
yeah.
If you got standard, then the routing should be based on what saves the company money.
Do you think it's a good idea to demonstrate your knowledge of leadership principles or company values in a system design interview? What do you think
Sprinkle
of
it in,
that?
but don't make it the main focus of the interview, right? Like make it known that you're capable of these things, but don't try to like modify the problem in a way just to
Yeah.
show off your leadership skills because that's not the focus of the this particular interview section.
Yeah, that is pretty interesting, especially considering Amazon spent like half of the time on a behavioral question, but you might as well
That yeah.
demonstrate the behavioral question, the behavioral capability during the interview. That would be actually pretty
Well, I don't,
fascinating.
I don't know how their rubric is, but do they have room on the rubric for the system design section to like note down how they did on leadership skills during the non-behavioral part?
Yeah, well, not exactly, but if somebody didn't do well on the behavioral but then demonstrated during the system design, probably a good idea. Another fantastic question. One turkey left the store A. Two users placed an order at the same time for one turkey. Do both orders succeed? And now it comes to the fallback strategy. What type of fallback strategy do you think is appropriate? Do you think it's appropriate for how do you would you load balance? If let's say the driver went to store A, they were not able to get a turkey. Now they went to the store B, they were not able to get a turkey. Now they're driving all the way to store C. Do you think it's acceptable for the driver to? How would you handle that in a system
I
perspective?
honestly, I think that goes into a reorder situation. I don't think we should be having this driver go from store to store to store to store like that, and actually delaying the one turkey that he did actually have.
Interesting. Yeah, I think that is all fantastic thoughts. Let's look at the boxes we have here. So this is Jerry.
Who's this? Jerry?
Yeah,
Okay.
so Jerry basically says that he is going to be designing a door turkey. Pay $40 and we deliver your turkey. All right, so thoughts. Realistically, not everyone is ordering turkey today. Most would order across the week leading up uh, or even before. Okay, time wise, we need to think about the number of turkeys in each region. If New York needs 5 million turkeys, how are we going to source them? Important to know ASAP, transporting across is going to be slow. Last mile delivery turkey in rural areas are all spread out and are going to be the most difficult to reach in the longest, assuming delivery drivers is the resource we need to constrain. Yeah, I think so far so good. I think these are some of the things we discussed as well. We potentially need to think about different regions, and I think Jerry here is hinting on the fact that potentially we need to think about turkeys and how constrained they are in each region and what is the supply demand for each region. So that's why I think it's very important to actually think about supply and demand. If you have a lot of turkeys, but you don't have a lot of drivers, it's going to be pretty challenging. You have to be batching more. If you have very little turkeys and a lot of drivers, you might be wasting everybody's time and canceling a lot of orders. So ideally, I would really want the winner tonight to be considering a supply demand service, possibly based on an ML model that takes into the account a lot of details such as the traffic, the number of turkeys left in the area, the number of customers active, the number of delivery drivers on the app. Stuff like this would be pretty interesting to see. All right, we need to minimize T such that all possible people get turkeys before end of day. But any earlier doesn't matter. So ideally imagine a few minutes before the end of day we finish delivery of all turkeys. That's pretty interesting thoughts. So we have an API gateway, off and boring stuff, love that. And we have order ingestion service. In theory, first come, first serve. In practice, probably everyone's ordering around the same time, rather than just optimize for delivery in batches, then queue up in immediate delivery. Interesting thoughts. Could be GeoHash here as well. So we have some basic schema going, and we have a persistent order DB, Postgres or Cockroach DB. Well, we can say that Jerry has been doing his homework, right? So I think we definitely should be getting credit for, I think Cockroach DB has to be writing us some checks, because we influence so many people to use Cockroach DB. And yeah, big shout out to Cockroach DB, but it definitely became more popular. What do you think about the DB choice here?
Okay, so for persistent order, of course. Let's see. Partition on geographic regions. I'm guessing CRDB definitely has geo support, right?
Mm-hmm.
Okay, great. Let me see. Cockroach expensive, or we're just doing this for one day. Okay, that's an interesting justification, and it's true. No matter the cost, we're only doing this for one day. SQLDB with strong consistency lets us resist
Issues with multi-transactions. So one interesting difference between Postgres and CockroachDB, and I would love for Jerry to talk a little bit more about it during his presentation. But one thing I have to say for sure is that the biggest difference between Postgres and CockroachDB is the way how sharding is done. In CockroachDB, sharding is done based on their own way. So potentially, we don't actually have a way to see how sharding is performed in CRDB. That makes the app slower because if you do sharding based on a logical maybe size of the partition of the data, then it can be faster. That's why Postgres is better for some apps than CRDB. That's kind of another like a very niche advantage between Postgres and CockroachDB. But overall, do you think SQL is the right choice Do you think Cassandra or DynamoDB makes sense for order service here?
Order service consistency over everything, so I would agree with Jerry here.
Yeah, I think I agree as well. I really like that. That probably is the priority. So now we have a batch delivery queuing service and the drivers. Very interesting. So bad delivery downtime, bad single delivery, not optimal paths. Wait, how long does it take to cook a turkey? Haha, interesting. Okay, we're going to abstract cooking time. Let's say delivered cooked turkey. Let's say delivered by sometime X in the evening. Yeah, what do you think about the batching queuing service? How do you think that should be actually handled?
Oh boy, that's the heart of the problem, right?
Exactly.
Let's see. Okay, wait, can you scroll up a little bit so I can see what arrow's feeding into the delivery queuing service?
I see. So this is basically a CDC to Kafka and Flink. Interesting.
Oh, okay.
What do you think about something like this?
I don't think I have a full grasp of what he's doing with this, so he either needs to explain it or zoom out a little bit so I can see this in context.
Yeah, I think he's using Kafka or Flink to ingest the orders from the ordering service to the queue and then batching them later.
Okay. Okay, but how are we actually assigning orders to drivers? Where's that?
That's exactly what I think it's missing, right? There's no assignment
Yeah.
service. There's nothing there that helps us out with something like this. So that is actually really interesting how that actually would all work. So batching consideration shouldn't just send a driver anytime. So we should wait. And then the rural area problem. All right, so he's talking about some interesting things.
I'm sure he'll explain it.
Yeah.
But we do want to check out Sniper.
Yeah, let's see what Sniper is doing. Wow, so Sniper's design is actually very different. Let's check out Sniper's database choice. So looks like Sniper also started with APIs. Let's kind of take a look at those. What do you think about those APIs? Oh, look, this is actually a very interesting problem. Search is based on zip code. I think this is going to run into the rural area / Manhattan problem, because one zip code in Manhattan is probably going to have a lot of traffic.
Well, I do think there's actually like thousands of zip code in Manhattan. I think that it's divided very
well.
it's
So do you
very
think a zip
divided.
code is a good proxy for
Let
the
me
number
check.
of people that live in an area? Because I know that the World Trade Center is actually has its own zip code. That's what I knew about New York actually.
Okay, so Manhattan only has 93 zip codes. That might not be. Well, a small town of
Actually,
50,000 people can have one zip code, so I think it's around the same
so
level of.
how many people live in New York, in
I
Manhattan?
want to say a million. I want to say a million, and then divide that by roughly
A
100.
million? That has to be at
Yeah.
least 15 million, I think.
No.
All right. All right, everybody in chat, how many people live in Manhattan without Google?
1.6 is correct.
At least 10.
It's
Interesting.
actually it is actually 1.6.
Is actually 1.6?
Yeah.
I don't believe that. That sounds way too little.
We're talking about residents, not people that like commute in and out.
Okay, in the previous design, how does a user know they will get an order? It seems to be a fire and forget. Oh, that is a fantastic question. It actually doesn't communicate, at least yet, how exactly that would be done. But definitely there should be a way how they can control the life cycle of the delivery. So the order ingestion service should be creating a delivery ID and the delivery UUID as well, or for users. So it looks like, they're definitely cooking something. Let's take a look at Sniper's design. So store ID. So the API is a pretty crud, kind of like a basic APIs here. Update the records, the driver service. Interesting. So we have the store service, caching layer. So I guess to me, okay. Oh, okay. So here's the thing. So Sniper is using a post API to reserve a turkey. Now, how would that work in a grocery store? Maybe the workers can come up to a turkey and put it aside.
Okay, he's assuming we have an agreement with the grocers like that. Well, we never said he couldn't do that.
Yeah. Honestly, this is a very open-ended question, We don't want to be too rigid, right? Because this is a system design battle. This is not an interview.
If you do this reservation, we can avoid the problem of having a driver show up and, the inventory said it was good, but it's just in someone's cart who didn't check out yet. So that's definitely a creative way to get around it. I'll give him that.
Yeah, that's for sure. So it looks like overall Sniper's design is less sophisticated. It doesn't have as many details. That is very interesting.
Well, I think he didn't put his thoughts on paper, but if he's able to explain them, then it's more than sufficient.
Exactly. Are you looking forward to the hacking round as well?
Oh, absolutely. Yeah, no, I think that will be
really fire.
Kind.
Yeah, I think
now it's really a battle.
Now it's really a battle, like a 1v1. It's like the Eminem 8 Mile, stuff like that. So maybe we should do a rap battle as well. I'll think about it. Maybe if you guys drop plus in chat and we get at least 10 pluses, we're going to do a rap battle next week. Anyways, so the user journey.
Does he say anything about database choice here?
Actually, I don't think so. That would be really fascinating to see a database choice. And it does look like the driver service updates the record as you drive. So potentially looks like a really bad idea to write to the order DB from a driver service. I'm assuming he's trying to update the driver location in the order DB.
Wait, as in like the driver's apps client?
Yeah, that sounds like a really bad idea.
So is the driver's app continuously sending information to the driver service, which then updates the DB, or how are they getting the information there?
That is weird. Yeah, I'm not really clear, but that seems like a really bad idea to write to the order DB from the driver service. Driver needs to confirm the delivery, but we still should not be touching the order DB. Order DB should be decoupled from.
Why is that going as you drive? Is he trying to store the location of the driver at all times in the order DB? Maybe he's gonna have to clarify that.
That is something that needs to be clarified for sure. And look, we actually have wow, I did not anticipate that at all. A caching layer in front of the store API. Very interesting.
I'm not a well.
I think
if a store becomes unavailable, that cache needs to be invalidated pretty quickly.
Yes, but how would you do that? And why would you need cache? I mean, let's say your store has 150 turkeys. How quickly do you think the cache can become invalid?
Well, we're not serving our consumers how many turkeys are at the store. We're serving them which stores are available, right? So it actually doesn't update that quickly. It doesn't change that frequently. A store is either available or not, right?
Interesting.
The consumer doesn't need to know how many turkeys are at the store. They just need to know if they can get one or not. We can abstract that away.
What if we show the consumers how many turkeys are available in a store? Do you think it's a cool feature?
I think that's overcomplicating the UI for the consumer, and it's overcomplicating the technical what we need to do on the back end to support that. So I think I wouldn't do that.
Yeah, I'm not a fan of cache, honestly. I think honestly, another thing I can also point out is that you have like 5 billion things going to the third-party grocery API. I think a good habit in a system design is to maybe put like a layer in front of the third-party API gateway and abstract it, or provide like an interface that talks to the third party, maybe like a third-party microservice or like the grocery microservice, and then provide a very nice API in gRPC that will allow your microservices to call that proxy. What do you think about something
Wow,
like
that's
this?
pretty interesting. So it's almost like a BFF that you're making for your
For the
third-party
third
API.
API, like a abstract client library for all third-party APIs, and
So
then
it's
put
the
it
backend for backend.
backend for backend for backend, or just spin up a new microservice so it's available in the service mesh, and then you can make gRPC calls, which then would make
So this
REST
is
calls
you're just doing this because you want your VPC to be like clean,
very
like
clean,
uh okay.
and you would want to, yeah, what I'm trying to do is that you would base in the real system how this would work is that you would have a microservice that has a NAT assigned on it, which is the network access gateway. And what it would do is that it would have both service mesh discovery options and an ability to make REST calls to the third party APIs. So you have a very clean gateway to those third party API
Okay, so
calls.
basically you just want your main microservices to be able to make a clean gRPC call to query third parties without directly
Exactly.
doing REST APIs to them. Okay.
But
Sure.
imagine you have to manually like hard code the API string for all these third party grocery APIs. Instead of just registering the third party service in the service mesh config and then having that discovered for you easily. Yes, you add like a little bit of gRPC overhead, but I think clean code is more important than 3 milliseconds of latency. I'm a big fan of just having a very very clean code. Especially look, yeah, he's already calling that from so many places.
Yeah, Bikes for Donuts, great question. Where is his gateway? Where is his load balancer? We don't see any of that.
Yeah.
Um,
Oh, interesting. He's tapping into the actual DB behind the third party. So the
okay,
inventory
so
DB.
that should have been abstracted away. I don't know why he's digging into that.
That is funny. Hack. Use the number of rows to determine if we can order from here. That is a bad idea.
If I was doing an interview, I would not be spending time like speculating how the third party's API works internally.
Yeah. Speculating
I
about third party APIs is definitely a bad idea. Backend for backend, some legend. Somebody in chat made this. Yeah, definitely legendary. Yeah, I would not spend our time here. Ooh, look, we're having geohash index.
wait, wait, why does the third parties like isn't it just for one individual store? Why do they care about where it is? It's just in their store. The DB doesn't need to know that, right? I don't know. Again, this doesn't matter at all. This is not our domain. We don't have to make this. It's already been done for us.
Yeah, people are asking how much time is
So,
left. We actually have about 10 minutes left for them to finish this up.
all right, you want to switch back to Jerry?
Yeah, let's see what Jerry's doing. Wow, that's a lot of stuff. That's oh god, reliability. Look at this message right there. That is crazy. Have you guys ever written down so much text in a system design interview? That is like a novel
I think he's making up for what he would have said
said
to us.
during the
Yeah.
interview, which is great
Also,
because this is a
we did
bottom.
not call in to Jerry. We did
Look,
not call
so
into.
yeah, it's fine. We don't need to talk to them. They're too busy making turkey delivery service. And I don't think, honestly, neither of them have questions. I think they're in their own worlds at this point. This is super important, but this DB current queue. Okay, so this way already went through this. All right, so let's kind of see what he's up to. So inventory preparation, we can use the combination of historic data and live data to smooth out inventory distributions, like I mentioned above. We can start doing this as soon as the day begins without waiting for orders, and then continue to do this throughout. Would also add padding, especially for urban centers, to have more turkeys than necessary. That is very interesting. So this is your load balancer. This is your turkey load balancer. What do you think about this turkey load balancer? I'm
Still,
I'm very curious
go
what
ahead.
he means by smooth out inventory distributions. That is a very interesting terminology right there.
Does he mean like smooth out spikes in orders, like temporally?
Yeah, that is very interesting. Basically, use an ML. Yeah, I think he's trying to use ML to predict the traffic. So,
Oh, oh, okay.
and then
Wow.
he's load
Um,
balancing based on the ML service. Wow, that is actually a really
wait.
good idea.
Okay, so kind of, so there's like a non-deterministic like AI that's basically deciding.
ChatGPT, you put in
Okay,
ChatGPT, hey, I have turkeys, and we
how,
want to
wait, but
load balance them.
MLs need to be trained. We're doing this for one day. Where the hell are we getting this information from?
Yeah, actually, that's a good point. How are we going to actually have an ML service for a company that only works for 1 day? I think if Sniper comes up with this during the hacking round, I'm going to give him a point for hacking into this pseudo ML.
I mean, yeah, what company would have data about like deliveries across the entire nation from the previous Thanksgivings, other than perhaps the biggest delivery apps right now?
Exactly. But stores have sold last year, but you don't having like even 10 years of data from the last 10 years. I don't even think that is enough for something like this to work reliably. I think Turkey sale pattern is extremely different from anything else. And also, don't forget that some people are going to be ordering on the Thanksgiving morning for the last minute turkey. That becomes even more sporadic. The owner of the turkey delivery service has had the grandparents go door to door to figure out how many turkeys were brought at each store. Interesting. Thanksgiving Day tradition since 1850. Yeah, I think it's a very interesting scenario that is happening right here. Wow. So, grocery inventory API, and then here we go. This is it. Looks like this is the backend for backend, the ingestion worker, and then the inventory DB. Oh, is that on Postgres? Don't need NoSQL more.
Okay, okay. I see what they're
Oh,
saying because there's going to be multiple different inventory APIs for the different stores, and he basically wants to ingest them and have a unified way to store them in a centralized database.
that is very interesting.
Whereas Sniper solution was kind of like the opposite.
Calling directly, but you know what
Yeah.
can crush this design completely? The
Hmm.
the fact that this ingestion worker is probably not going to be keeping up with the demand, and
Well, I'm sure there's many, many ingestion workers.
but are you going to like how frequently? Oh, you know what would have been a great idea is to have cadence or temporal run workflows and activities every 10 minutes and update those inventory things
I don't think 10 minutes is fast enough.
every 5 minutes. And then temporal basically goes, gets every starting point, and then within every starting point, it would update the inventory DB partitioned by every area. I think he's on the right track with the ingestion worker, but if I was Sniper, I would be definitely hacking into this area as well. Looks like, ooh, what do I think about Zookeeper? Just notice there's a Zookeeper. Make sure things are alive for reliability. Every second lost is big. What do you think about having a Zookeeper as like an internal infra reliability service? Do you think there is space for Zookeeper to be doing the heartbeats, and or do you think this is really overcomplicating steps, stuff?
I
Because
I think you could have abstracted this away and not dug too deep into this.
yeah, Somebody in the chat says, I thought Zookeeper was for service discovery. Well, I think the modern ways to use like service mesh, XDS for service discovery. I think Zookeeper here used in another traditional way of just architecting the system. So the way how Kafka works and is implemented is based on having multiple brokers, and if one broker goes down, Zookeeper can reassign the new ones and spin them up. I don't actually think that Zookeeper makes sense in order ingestion service or the batch delivery service because, first of all, it's stateless. It doesn't matter which one goes up and down. I think having just a load balancer and multiple nodes for every service should be good enough. So yeah, we actually have about 3 minutes before they have to wrap up the design, but let's take a look at the sniper design and see. That is very fascinating. All right, the sniper. Looks like sniper is updating some last minute APIs.
Did Jerry write down his APIs? Can you switch back?
No, I think Jerry went with a classic E6 approach with no APIs.
Yeah, I was about to say that kind of shows the seniority that he focused on the big picture.
Exactly.
More than...
Like if somebody shows up to the system design interview and they don't write the APIs, they are either very senior or very junior, right? Again, we have the bell curve. All right, turkeys lost forever are irreversible. What do you think about that?
What's the context?
Definitely need Zookeeper. That is very interesting. What do you guys...
If driver dies, assume delivery failed, resend. Okay, well that's actually what I was saying before. If they come with some unrecoverable issue, then we should actually cause a reorder rather than trying to salvage it.
Interesting. And then you would just refund the customer?
Well, no, actually, you're just causing a reorder, and it's gonna the order's gonna be reintroduced into your flow, and it's gonna start all over with another driver, basically.
Yeah.
We're gonna try again.
Yeah, that is very interesting. Also, what do you think the chances of them stream sniping right now?
No, I think there's honor among engineers.
Honor.
So I'd say pretty low.
Yeah. Jerry has, overall right now looks like Jerry has a very huge edge over the design. Like Jerry's really going down.
He looks like a crowd favorite.
He looks like a crowd favorite as well. Yeah, Sniper's design is very interesting. You know what? I'm really excited for the hacking stage. And people from chat also feel free to hack as well into their design. I think it's going to be really fun.
All right, I think time should be about up.
Yeah, we have about 50 seconds left. Let's go ahead and call them up and let them join back to the stage. All right. Let's see if Jerry picks up the phone.
Oh,
Hey, Jerry, time is up. Please join back the stage.
okay.
All right, thank you. All right, let's go Sniper in as well. All right,
Hey.
Time is up. Join back on stage.
All right.
Thank you. All right, guys, big round of applause for both brave candidates who
And
went
for the
in.
chat, by hack we mean like point out flaws in the other person's design.
Yeah, that's going to be a hacking round. So it's going to be 15 minutes per person for presentation and hacking. So Sniper is back on stage. Jerry, please join back on stage. Raise your hand so we can invite you back on stage. All right. So now we're going to have a 15-minute hacking round. And we're going to be deciding who is going to win tonight. And I think...
So that's 15 minutes combined time for presenting and hacking the other
Exactly.
person's design.
Yes.
So they get to choose if they want to be on offense or defense, how much time they want to allocate to each one.
Mm-hmm. Yeah. So
Okay.
Oh, Lord.
All right. So who wants to present first? Who wants to get the first mover advantage?
I guess I'll go first. I already took up. I just peeked at Jerry's design, and his looks a lot more complex than mine. So I think if I just get mine out of the way faster, Jerry can spend more time on his stuff.
Hey, looks can be deceiving. You don't know.
Yeah, looks can be deceiving. How do you know? What if we find a lot of flaws, right? Because when Jerry puts a lot of boxes into the design, there's more areas for you and for the audience to hack. And
Maybe.
if Jerry's design falls back on, being realistic enough, that can, get you the victory.
Maybe.
All
Yeah.
right.
So I guess I'll sort of go over my design. So before I want to start, when I thought about this problem, I kind of realized after Harry was talking about it that, fundamentally this problem that we're designing isn't all that much different from a ticket reservation system. So I kind of went with my design with that, saying, if you think about it, ordering a turkey is kind of like ordering a ticket in an event, right? So, you go to a store, you reserve the turkey, and you get you get an item ID, which you can then reserve and then do that.
Mm-hmm.
Wait, sorry.
Yeah, sorry.
I think
Uh-huh.
Excalibur is bothering me. So, fundamentally, I decided to sort of, since backend isn't really my specialty, I decided to just kind of mirror this with the user journey. So basically, we have a client who decides that. Wait, can you guys see this okay, or are you guys here to like?
Yeah, we can follow you, okay? Can you
All right,
guys
so
see the chat,
okay.
okay? Just making sure.
Yeah, I just saw in the chats people were saying that they couldn't read it.
Awesome.
Yeah, the
That was
fidelity was kind of low, but now I can read it. Cool.
Awesome.
All right. So yeah, just let me go over the user journey. So, my design kind of leaned towards that. So, we have our client here to start and saying, our client is probably going to search for a stores with their zip code as a proximity. And, in the beginning, when they search for a store, I actually thought that when Harry said we can kind of like delegate to a lot of third-party APIs, I kind of realized, I can actually kind of hand wave a lot of the details over the search because, our third-party API probably already implements that kind of search for us. So if I say search by, zip code, the third-party API probably already did a geo-indexing of all my stores. So it's like user searches for the store service calls third-party APIs, and it will give you back the stores which have turkey counts of greater than one. So it'll appear on your screen, and you'll be able to search. From there, the client will be able to sort of reserve or request from that store saying, hey, I want to order a turkey. So go to the reservation service, you call the third party API again, and this is where the magic happens, where, and I should really, sorry, I kind of realized I should have put a status here, but, if I have a reservation, I call a third party API. The third API probably has, tables in the back that sort of track these orders. So when I reserve, the store ID or, this store DB indexed by the search will basically decrement the count and it'll create a record of an item that's being checked out. So these two tables are pretty close together tied. And I wrote here that, in order to ensure the strongest consistency that, we're going to wrap that transaction in a single like statement to make sure that these never fall out of sync. But anyways, so now that you've reserved it, we get a reservation. The user goes back to their client. They get around 10 minutes to order the actual turkey, and upon a successful order, assuming that they actually do this in time, I wrote two pads here saying, update the cache upon successful order, and then call a third API to order the turkey. It updates the third party API, and it once again updates these records to ensure that you can, like, this transaction is firmly in place. Nobody can order that item ID anymore, but otherwise it would get released back. So all of that said, we go to the order service, go to the orders database, we create a new entry for that orders that the user just placed, and there's going to be a set of third-party APIs or even like a separate implementation of a driver service that sort of tracks the status of the order. But I just said immediately, like, it'll get sent to a driver service. They'll probably do a bunch of orchestration here, and the driver has a put on the order that allows them to sort of update the record. And the way that the user would be able to see this is that every 5 or 10 seconds, this client will update and recall the API to show you what the status of the order is. And that's kind of the lowdown of how I decided to implement this. But as I said, I really designed this in mind with the idea that this isn't really all that different from like a ticket reservation system or like restaurant reservation services. So I went with that, but I might have missed the prompt entirely, honestly. So yeah, that's sort of the lowdown of how I decided to go about this. You guys have any questions?
Yeah, Jerry, you may begin hacking the solution first.
One is like, how do we handle deliveries?
I assume that those would actually be handled either by a third-party service or, I actually never really thought that far into it because like I said, fundamentally, I think what's more important is that we create an interface over these disparate APIs to be able to order on behalf of these stores. So in the end, we make an order and then we probably have some other delivery service with its whole other infrastructure to be able to handle that. But yeah, that's something I did end up missing because I was more concerned with how do we ensure that people can order.
Okay. So then if I'm in New York and all the stores in New York are sold out, then there's chances are I need to get one shipped in from like, I don't know, Pennsylvania, and then that'll take forever then?
That might be an edge case because I realized, if you're in New York and probably all the stores are sold out, you'll probably have to search for another zip code, right? And then, eventually, you'll be ending up with a very sad Thanksgiving because all the stores in your area will be searched or sold out when you searched all the nearby zip codes that, are within a reasonable distance. But I said, let the user select the zip code so that they can make that choice themselves. But I realize that's probably not the greatest user experience, but it does sort of get around the idea of like, well, we should probably manage the search somehow.
Okay,
yeah, that's
and you
a
talked
good
about
call out.
like searching by zip code. Could you elaborate how that works a little bit?
Yeah, so I imagined with your search that your device will probably have some kind of approximate location for where you deliver it, and then it'll probably grab your zip code from there. But I sort of get what you're saying, where fundamentally they're trying to deliver your address, but if you search by zip code, there is a mismatch between like delivering by zip codes versus delivering by address. So yeah, that is another miss on my part.
Okay. Do we keep track of inventory?
Yes, we do. So that count is
where-
actually the inventory. So that the inventory DB sort of tells us like what has actually been reserved for like a particular store. But even then, like there's going to be a very easy count to determine whether you can order from that store because when I create this record in the inventory DB with the item, that does correspond to a store, and in that same transaction, it sort of says, I'm going to decrement this count by 1.
Yeah. So to be clear, like the inventory DB is essentially a replica of the store's DB that they have for amount of
they would be
cookies.
tracked separately.
Objection.
But, I mean, maybe it is possible that we could consolidate these two tables into one.
Objection from the judge. Why are we speculating about third-party APIs again?
Didn't we say in the beginning that we had a sort of abstraction over like these brochures that had their own APIs and that we would call them?
Yeah.
Or is that
Exactly, it's abstracted. So why are you
Abstracted.
looking into like what DB
oh
third-party
well,
APIs
I would
cause?
have assumed like you would have asked me, it's like, oh well, how do they do that? Versus I might have concerned myself with like, am I hand waving too much details, or like would you have actually wanted me to sort of like go into how they implemented their APIs? But
There were,
yeah.
yeah, so basically there were so many other things to focus on. We would have been totally cool with you hand waving this third-party API.
Yeah, because
But you live,
yeah,
you learn. That's fine. That's
yeah.
fine.
I mean, this is not that big of a deal. I mean, because either way, that explains your design. I think if you just had this DB on your side that was, transforming the APIs, that would have been just a little cleaner, because we don't want to speculate about something that we don't have controller access up to. But it's completely fair that requirements were quite a bit ambiguous. All right, we may now take criticism or hacking attempts from the audience in chat. So if you have any
Wait,
hacking, uh-huh.
I had one more thing. I
Yeah,
had
yeah,
one
go
more
ahead, Jerry.
question.
Go ahead.
Essentially, okay, if we're doing that orders and we're sending it to their gateway and send it to forward like these orders, right? So why do we need a reservation system if they're handling those?
I guess that's a good point. I guess I mainly did that for like customer experience, saying, I don't want them to, in the middle of the checkout flow, say, okay, well, I tried to make an order, but in the middle, I can no longer order that turkey or from that store anymore. So when I made that reservation, I was going to make a distinction on this inventory saying that this thing is either reserved or, it's been checked out, or, the item isn't in the inventory DB, then we can safely assume that a new ID will be generated and that will be that order to track.
Okay, okay. So we reserve the turkey with the grocer and
Yeah.
then confirm it. Okay, got it. Cool. Okay, I'm done.
All right, thank you, Jerry. The judges and the chat may begin hacking Sniper's solution. We have about 3 minutes left. So I guess I can open up the first question in terms of this one. Can you talk a little bit more about the database choice and describe what database are you using and what exactly driver service is writing to the order DB?
So I did sort of put that at the end saying, when the driver service updates the order, they're going to probably call this endpoint, which is like put order, and they'll say the order ID, where they're at, and the status of that order. But I guess I didn't really get to talk about database choices, but I thought, the structure of all this data is sort of like locked in place, and it doesn't really have like a complicated schema. So I said, maybe we could just probably use like a SQL database. There's probably going to be a lot of writes to this, so we might go with a database that's extremely like good at handling that many writes at once. So maybe CockroachDB, your favorite.
Yeah.
So that's a possibility, but there are certainly ways that we could use like other databases that might be on the cheaper side, that if I had time to like implement the actual like driver service and like how it handles like doing the writes, then probably I could have used a different database. But we don't have a lot
Just
of time to think about it. Probably Cockroach.
just to confirm, the location field is storing the live location of where the driver is with your order.
Yeah, like the lat and the long.
Okay, I
Inside
would
the order
totally
DB.
Oh
that
yeah,
yeah, that
I
would be
said
it.
destination twice. Like
I would definitely have to pull out location into like a Reddish cache or something like separate, because it's getting updated so frequently for every single order. If that could be stored in cache and then the rest of the order to be could stay as it is, I think that would be better.
yeah, that's certainly true. I realized a lot of even if the API only gets called like every 10 seconds on the client, that's still a lot of
It's
people
so
looking at their
much
order statuses.
updates.
So
Yeah.
yeah,
Yeah, unfortunately, I think the concurrent number of concurrent connections to the DB would be the biggest bottleneck, and that would not be able to process millions of drivers delivering turkeys. So yeah, that is something that I wish was decoupled from the order DB. Additionally, I would say that OrderDB is a tier 0 service. And if you bring a tier 0 service down, that is unfortunately non-forgivable. We can't afford to bring a tier 0 service down. Because if we
Wait, and you're seeing where your orders on the map might be tier 1, right?
exactly, or tier
Because
2,
it's not critical. Okay, cool. Yeah, that makes sense. Decoupling tier 0 and tier 1 or
tier 1
2 services.
services.
Yeah.
And that kind of makes sense. So we're actually out of time. So thank you, Sniper, for defending your design, and thank you, Jerry, for hacking, and everybody in chat hacking this very aggressively. I think it was certainly really fun. And now we're gonna switch sides. Jerry, your 15 minutes of fame begin now.
There's way too much text on my screen. I can't finish this. Okay, so
We read
basically
most of
there are a
it.
lot of thoughts.
Yeah,
Okay, great.
we read most of it, so we have context with the chat.
Great. So I don't care where you're ordering from. Just give us $40 and deliver your turkey. Okay. So that's what the service is. Ostensibly, like real in practice, no one's gonna like not 300. I mean, not 50 million turkeys are gonna get ordered today. But okay, for purposes of this exercise, they are. Time wise, we need to think about the turkeys in each region. This is addressed below in the inventory distribution service. So in terms of the API, something that I did differently was that I just assumed it was essentially grocery inventory API. You can see my mouse, right?
Yes, we're following you.
Okay.
Yeah,
okay.
I can.
So essentially, we just ingest all the data from the grocery API, and then we own it. So we have this inventory DB. Honestly, the way I set everything up, everything is essentially sharded by geolocation. So imagine like every city center, or every county has its own like service dealing with it. The only cross region sort of service is our inventory distribution service. So you can think of it as essentially like a hub and spoke model. But this is modeled. I also mentioned this. Everything I talk about is going to be mentioned somewhere. But for flights, essentially, there's a hub and spoke model where you have these important distribution centers, and then they get sent out for delivery for last mile. So we're just going to have these grocery stores as our distribution centers, and we're going to even up the distribution based on predictions and like active historic data, as well as like active forecasting. Does that make sense? This is our inventory distribution service. We have some drivers that just do hub-to-hub deliveries to even smooth out the inventory. Because for that New York to Pennsylvania example, for example, that I did. And then we have a DB for pending transfers for recovery purposes. Because we sharded up the geography so bigly, we actually don't need like some highly scalable DB like Postgres. Honestly, is probably okay, and we would prefer that for less complexity and more consistency, right? API gateway, client, normal boring stuff. So we care a lot about the last mile delivery. So that's something that I spend some time thinking about. Something that's really interesting is there's this secretary problem, which is like, if you don't know what the expected value is, like how do we know when we should fire it off? And the answer is essentially about 37% over 1 over E. So when we hit about 1 over E of the optimal, that's probably going to be a pretty good guess as any. So we can send out batches once we hit 1 over E distribution in a particular like neighborhood saturation. And interestingly enough, this also deals with the rural area problem. Because essentially, if there's only one house in a region and they order a turkey, then that surpasses 1 over E of number of houses in that region that we predict to buy turkeys. So then we should send one off to them immediately, which is interesting because the rural areas, they're particularly far and there's not a lot of houses. So it's important for us to get to them ahead of time. I said like we should send the fastest cars or even paradrop them if possible. Yeah, that was kind of funny. I'm gonna assume we don't care how long it takes to cook a turkey. They're somehow cooked already. The cooking in the car. Any other important things? Did some napkin math. Even if people are ordering like around the clock, Postgres should be able to handle it. Especially because we're sharding. We want to reliability came up near the end. That I forgot. Like, oh, we should be reliable. Not particularly difficult. We should have Zookeeper to make sure everything has a heartbeat and is still staying alive. So maintain those services as much as possible. And then what's interesting is if a delivery driver dies, So I don't know if you read this section. Ostensibly, we lost those turkeys forever, which is bad considering we had limited inventory to begin with. So if we tape GPS attachments onto each driver, we could send up a backup driver to pick up that turkey. The number of actual drivers is going to be like compared to like the number of turkeys being ordered is going to be very small. You can just keep track of that locally. We would probably have a logistics team. They would probably have just a small local map and the GPS's ping. I wouldn't send that to the customer necessarily. One thing that I do, so this design doesn't have compared to Sniper's design is it doesn't have the show where your driver is on the map. Okay. Any other questions? Any questions? I kind of glazed over.
So going over this, I guess you didn't really handle how do you actually keep track of like if you can order from a store versus you can't order from a store? Maybe this detail kind of flew over my head because
we are an abstraction. So we say we have turkeys. Buy a turkey or not. You can't choose the particular store. We do that for you.
Okay,
His whole business model is $40. We get you a turkey.
Sorry, go ahead.
No matter what. So it seems his whole business model is $40. We get you a turkey. Don't worry about where it came from. It's gonna come to you $40, right? Am I correct?
Yeah, that's exactly right. Yeah.
Okay, so it's like that problem of where the turkey is available from. Our service takes care of that.
Yeah.
Okay.
So what I'm trying to optimize for, and I did write this somewhere, is like trying to minimize T so that all possible deliveries get to the people before the end of the day.
Right. Okay. Yeah, I mean, to be honest, this is already a lot better than my design. I can't really think of anything except for what I just asked, which is how you actually keep track of whether somebody can buy something or not. But
do you mean like I mean, we have like an inventory DB, but I mean, the assumption is there's always inventory, because I mean, the question that was given to us is like, we have this many turkeys and we're going to deliver them. I'm assuming we don't sell out. If we do sell out, then I mean, we can't really do much more. But because we have this prediction inventory distribution system, then we're going to get as close to selling out as possible. So if like this center is getting close to empty, then we're going to send some drivers from nearby centers that have too many, and we're going to send them over. So essentially, for your purposes, assume we always have inventory. Does that make sense?
yeah, okay, that makes a lot more sense, and it's generally interesting because my design was more focused on doing the actual like purchasing versus yours, which is you already made a decision that that's handled by some other service, and we're just handling being able to get it to the customer. So yeah. And I mean, as I said, I was focusing more on like, well, can they reserve it versus you as like, I modeled this after Ticketmaster, but you modeled this after DoorDash, as you say. Yeah, like GoPuff.
Something like that, yeah.
Yeah.
Very
I think
interesting.
for me, I think the interesting side was like getting the deliveries, right? Think about the deliveries, and I think the hub and spoke model is the particularly interesting realization. So that's what I chose to spend more time on.
Okay, pretty interesting stuff. We have about 6 minutes left on hacking phase. People from chat, I'm actively encouraging you to try and hack Jerry's solution. Looks like some of the questions are there, but one thing that I would like to challenge here is the inventory worker, the ingestion worker from the inventory API. On what frequency and how does it work, and how do you deal with the fact that your data is updating very quickly?
Yeah, I mean, I thought about this a little bit. I think grocery stores, I mean, most non-tech companies, if you've ever worked with them, their tech sucks compared to tech companies. And I'm assuming we're a tech company. Yes, so I just ingest their information once at the beginning of the day, and then afterwards we take over, right? And in fact, we take over the entire warehouse. We said, this is ours now. And then we might move more turkeys into their inventory and then out. Does that make sense?
So you're poking into the implementation of their inventory system. You're basically
No,
replicating.
no. I don't have a fridge. I'm using their fridge. Does that make sense?
So
Or I mean, ostensibly, we could spin up a fridge. That's an implementation detail.
spin up a fridge.
I
Where are
didn't
you
know
gonna
fridges
store
were on AWS.
Alright.
frozen turkeys, dude? This is
Which
what they mean
AWS
by cold
services?
storage, by the way.
Okay, that's what cold storage means. Okay, so you're using S3 Iceberg, is that right?
Yeah, that's exactly right. No, I mean for abstraction purposes, it sounded like we have like access to their warehouse, as much as possible to take like turkeys out and in. If we don't have access, because for my inventory distribution, it might be that I need to back up turkeys from somewhere else to go to the Whole Foods in New York. I need to store them for a while. If I can't store them there, we would need to rent our own facility to freeze turkeys while they're
Whoa. That is very
okay.
interesting. So you are actually moving the turkeys into your own
Yeah.
fridge.
Wait, not his own, but he's basically saying, "Oh, if the shop right here has too few turkeys, we're gonna make a driver drive them in from a different shop right on a different
Yeah,
town and balance the inventory out throughout the
Oh, so
system."
you're doing your own load balancer, your own
That's yeah,
your own
yeah.
like
yeah,
rebalancing.
that's exactly right. Yeah.
That is insane. Load balancing IRL. That is very
Yeah, I saw
interesting.
someone in the chat saying like, how do you do this sort of ML or like predictions when it comes once a year? Essentially, when you like log these sort of purchases, you'd have a timestamp on them, so you would get a sense of a timestamp and a location. So you could, for example, see which areas buy in the morning a lot, which areas buy more than other areas, and from these you can be able to make predictions, even though they
So
come
you're
just once
basically
a year.
just saying use last year's data.
Yeah, exactly. Well, I wrote about this in the predictive forecasting notes. Essentially, you like proportion population to the total. You can use past data into sort of last year's, but you can also predict based on like the past hours data. If more people bought in the last hour than predicted from last year, then you could increase your forecast by 20%, for example, for New York. Does that make sense?
That is very interesting. To be honest, I'm still very surprised by the cold storage and the IRL load balancing. I think the challenge that I have with that solution is that you actually don't have enough time to load balance the turkeys because how are you going to drive a turkey from Pennsylvania to New York? And how much is it going to cost? Like at what point like your service is no longer profitable because you're
Well,
just load balancing
yeah,
turkeys.
you would have to eat the cost because of the flat fee for every turkey.
Yeah,
Yeah.
very
Yes, for
interesting.
sure. We could talk about the costs, but I don't know what the
Well,
costs
actually,
are.
if you're doing hub to hub transportations, you're not bringing one, you're filling the whole car.
Exactly, yeah. So we probably have some sort of threshold, like if we're not bringing like sufficient turkeys, it's not worth the trip.
Yeah, very interesting. But I'm still not sold on the idea how the ingestion worker would populate this API data and
Okay.
load balance the
Wait.
storage. Like, what if the API fails and you have missing data? Like, how do you make sure you don't set like you get like a zero from your ETL job that transforms the API data to your own storage, and then you accidentally deploy a track of turkeys to somewhere where you have missing data? How do you handle those edge cases?
So how do you handle if the API fails or like you have some missing data?
Yeah, are you going to be deploying tracks? If there is a missing data, or
Yeah. Well, so what's nice about the API is honestly you could do that beginning of the day. You could do that like a week in advance, or just a day in advance, right? And with that amount of time, essentially you could have exponential backoff. You would monitor the health of these services and make sure that data is aligned with those groceries inventories at the beginning of the day. And like literally, you could call up those grocery stores if like in the morning you're like, oh yeah, this service failed. Your service sucks. Can you guys tell us what the actual inventory is
yeah?
in this store?
Okay.
So because we can prepare this ahead of time, it's kind of like cheating in like a leak code problem. Like when you can prepare your data structures ahead of time. It's a lot like that in my head.
That is crazy. Okay, that is very crazy. So you're basically using like a template. Yeah, that
Yeah,
is
it's
very
like rainbow
creative.
tables, right? We
Yeah,
pre-compute everything. Yeah.
that's definitely very funny, just like the cold storages. All right. Can you elaborate?
I guess
Uh
one
huh.
thing I want to say, so I guess now that I look at this, like this is like a very asynchronous system versus like what I did, where almost everything I would have built was like a REST based thing. But again, as I said, that's probably just because I focused on like the ordering side versus you're on the delivery side. So I guess in your implementation, everything is a lot more asynchronous just because it is a lot more involved with like updates that might not be reliably, transactional or on time or something like that, right?
Hmm. Um,
Okay.
you're absolutely right. I mean, when you so if you look at the top of this diagram, you can see like the order ingestion service, and this is you know pretty synchronous. But for the batch processing, you're right, it's not synchronous, and the reason is I actually wrote it here is you don't want to send out a delivery driver as soon as you have one order. You want to have some sort of because that's just inefficient in terms of drivers. I just assumed that drivers were going to be our constraint. So yeah, with that assumption,
Interesting.
I move forward.
So that's yet another load balancer in your system, essentially.
Yeah, you can think about it that way. Yeah.
Yeah, I mean, makes sense. I think I love the CRDB choice as well, and for the database potentially. I'm not a fan of the Zookeeper. I personally prefer Kubernetes and deploy microservices and then letting
Okay.
Kubernetes handle everything rather than everything. But I don't think that's the end of the world. So
Yeah.
yeah, that wraps up for Jerry's presentation and design. So everybody, round of applause for both Jerry and Sniper. Fantastic job. Both of you guys did. And now let's spin up a poll for the audience. So the audience is going to be voting first. And I'm going to go ahead and do this on YouTube. Let me go ahead and create a poll. And Chompy, can you go ahead and create a poll on Discord as well? All right, everybody, round of applause. Both participants did an amazing job. Let's see who is going to win tonight. All right, is Chompy still here? Oh, looks like he has an issue. All right, let me go ahead and do this. All right, let's go ahead and see the results. And looks like one of our judge, the Chompy, something happened to his internet. All right, so he just DM'd me privately his vote. He had to drop, and let's have everybody vote as well. All right. Looks like Jerry is leading 60-40 on YouTube and about 70-20 on Discord. So Jerry is definitely audience favorite. But let me kind of do a quick rundown of the design. I think that Sniper did a pretty good job creating APIs, which I don't think Jerry did. And it's totally fine not to have the APIs, especially for a more senior level. You can't skip them. So my take is that if you don't have APIs, you're either very junior or very senior, which makes sense. In Sniper's design, the whole articulation makes sense. We did go over this during the stream, but we're not a fan of the third API grocery ingestion. It was a little bit unclear how microservices would call this API and propose to have a microservice that abstracts this communication with the client to simplify the process. Also, we talked a little bit about how drivers server has to be decoupled from the order DB to separate tier 0 servers from tier 1. But overall, the design is functional and I think it works and fulfills the requirements. On Jerry, we have a really, really fascinating design. I think the turkey load balancing and, it looks like Jerry, paid a lot of attention to scalability and availability. And overall came up with a really fantastic design. I'm really happy with the DB choice. The order ingestion service also makes a lot of sense. Additionally, I think Jerry put a lot of care into the edge cases, and without a doubt, I think today's winner is going to be Jerry. So congratulations, Sniper and Jerry. Both of you did a fantastic job, and you guys did absolutely amazing. But Jerry, congratulations, you won the grand prize, which is a complimentary session with a mentor to help you prepare for your interview. So we really appreciate you guys' time today. And yeah, congratulations, Jerry. You please reach out to me in DM, and I'll get you the promo code for a free session with a mentor who can help you with your upcoming interview.
Awesome. Thank you.
Yep. All right. Thank you, Easy Climb Tech, for sponsoring today's stream. If you guys are looking for mentors to help you prepare for system design, coding, and behavior interviews at FAANG, thanks Easy Climb Tech for sponsoring us tonight. And yeah, appreciate everybody tonight. I think it was really fun. The recording will be available on YouTube as well. And yeah, thanks for both of you guys, and see you guys soon.
Can I just say, like, I can stay in the main chat for a little bit and answer questions for anyone who has more questions about my design?
Yeah, we can chat after stream.
Cool.
Yeah, can we do
Sounds
this
good.
more than
Thanks.
once a week? For sure. Yeah, we have a big tournament coming up. So we're drafting a tournament with a big cash prize very soon. So we're currently in talks with some sponsors how would sponsor like a full 16 people tournament and then have top 3 people win some cash prizes in this exact format. So guys, stay tuned. Please subscribe to our YouTube channel. We would really appreciate this. Your guys' support. You guys are all absolutely amazing, and none of that would have been possible without you. Here's the YouTube channel link as well in the Discord. And yeah, if you guys want, looks like Jerry wants to chat a little bit in the main chat. Jordan has no life is disappointed that none of this you are using Flink. Yeah, that is for sure. All right, thank you so